Hello everyone, good morning. Today I am going to discuss how to calculate the E0 cell of any half cell reaction. Now, we know that delta G naught is the standard Gibbs free energy change, and that is equal to minus n, which is the number of electron involved in that redox reaction. F is the Faraday constant, and E0 cell is the standard electrode potential. Delta G or delta G naught is an extensive property, that is they can be added. Yes, if you add two half cell reaction together, then the delta G corresponding delta G values can be added. Whereas E0 cell is an intensive property, so you can't add the E0 cell of two half cell reaction. Now let's see a simple problem based on it. Given the E0 values for the following reaction sequence, here manganese in plus 6 oxidation state, when it goes to Mn plus 5, the E0 cell value is 1.28 volt. From this to this much volt. From this to this much volt. From Mn3 plus to Mn2 plus, this is 1.5 volt. Now we have to find the value of E0 for Mn6 plus to Mn2 plus. Okay, so let's see. First is Mn6 plus to Mn5 plus, that is 1.28 volt. So what is the delta G naught? Let's see, it is delta G naught 1, and it will be minus NF E0 cell, where N is the number of electrons, so it has gained 1 electron, so 1 into F into E0 cell is 1.28. so delta G naught 1 value is minus 1.28 F. Okay, now let's see another. Mn5 plus to Mn4 plus, it is 2.9 volt. So again delta G naught 2 is minus N is again 1, it has gained 1 electron, so 1 into F into E0 cell, that is 2.9 volt, so it is minus 2.9 F. Similarly 4 plus 4 to Mn plus 3, it is 0.96 volt, so delta G naught 3 in this case will be minus 0.96 F. for Mn3 plus 2 Mn2 plus, value is 1.5 volt, so it will be delta G naught 4, let's see, so it will be minus 1.5 F. Now this is our target equation, that is Mn6 plus to Mn2 plus. So how to get this particular half cell reaction? If you add all these cell reaction 1, 2, 3 and 4, so Mn5 will be cancelled out, 4 will be cancelled out, 3 will be cancelled out. Overall reaction will be Mn6 plus changing to Mn2 plus. Now let's see, delta G naught for this reaction is minus N, and here N is, it is taking 4 electron, so 4 into F into E0 cell of this target equation. Now we are adding this first, second, third, fourth equation to get this final reaction, half cell reaction. Then in the similar way we can also find the delta G naught of this required equation by adding all these delta G naught values. So we can say that delta G naught equal to delta G naught 1 plus delta G naught 2 plus delta G naught 3 plus delta G naught 4, and simply say, so you can write minus 4 F E naught cell equal to minus 1.28 F, you take negative as common, then plus 2.9 F plus 0.96 F plus 1.5 F. So negative negative will be cancelled out. If you can also take F as common, so 4 into E naught cell will be equal to sum of all this. If you add all this, you will get 6.64. okay, F is also cancelled out because F is in common. So E naught cell value is 6.64 divided by 4, so it is what, 1.66 volt. So for this particular reaction, the E naught cell is equal to 1.66 volt. That is the correct answer. Okay, so we can't add the E naught cell only of these 4 reaction. We have to add delta G naught, because E naught cell is not extensive property, it is intensive. So we can't add the intensive properties that are not additive in nature. Okay, so final, for the half cell reaction going from plus 6 oxidation state to plus 2, the E naught cell is 1.66 volt, that is positive. It means that this reaction is a spontaneous in forward direction, or it is feasible reaction. Thank you very much.